Welcome to the lesson on selecting the best n-grams, where we are going to discuss feature selection techniques for finding the most informative n-grams. So here's the thing about n-grams. There are so freaking many of them. When we use bytes, considering that there are 256 bytes, and when we count the number of n-grams, it's going to be 256 to the power of n. Even with a really small n, like 4, you get about 4 billion possible n-grams. And that would mean that if you use n-grams as your feature vectors, they're going to be of size 4 billion, and that's just too much. For that reason, we want to find a way to cut down the number of features. The problem with too many features is not only computational, but sometimes it can actually reduce your performance and make your algorithm not converge. So what we do to solve this problem is employ feature selection. Feature selection is a technical term referring to a type of techniques that are theoretically backed and are meant to transform your features to something more tractable and at the same time predictive, so your algorithm can use the new features and have good performance. And the type of feature selection technique you use will depend on the data and the features. When it comes to n-grams, we're going to learn about 3 feature selection techniques. The first one is selecting the most frequent n-grams. Although this is not a very sophisticated feature selection technique, it has been experimentally shown in the literature to be just as good as the more sophisticated theoretically backed techniques, and it offers the advantage of being very fast. The second technique we're going to discuss is mutual information. This technique is based on the ideas of information theory and how one random variable can be highly correlated with another random variable, meaning that the two have a lot of information in common, so you can just use one variable in place of both, since you won't be losing any information by discarding one of the variables. And the third technique we're going to be covering is called chi-squared, which is a famous technique from statistics. So let's start by loading up all the code from before, the same code that we used to extract the n-grams. Go ahead and specify the location of your samples, benign and malicious. And now we're going to collect all the n-grams from all the files. We're going to get a huge frequency table, and it's going to consist of the counts of occurrences of n-grams in all the files that we have. Having done that, we're going to extract a smaller proportion, and in this case I'm going to take the most frequent 1000 n-grams. And I'm not going to stop there because I'm going to use these in my feature selection. So I've already filtered down to the top 1000, but we're going to apply feature selection once more. But we're going to apply our feature selection to this 1000 because if we use all n-grams, that will be computationally very challenging. So we now have our list of the top 1000 most common n-grams. And from now on, when I featureize a sample, I'll only use these 1000 n-grams as my features. So to recap what we've done so far is I've looked at all of my samples and I constructed a frequency table of all the n-grams for all the samples. Then I filtered this huge frequency table to the top 1000 n-grams, and now I'm going to use those as my initial features. After, I'm going to apply feature selection to further narrow these down to the most informative features. So let's go ahead and featureize all the samples. Having accomplished that, I now want to import my libraries to perform feature selection. And I also specify that I want to narrow down my features to, let's say, 100 features when I'm finished applying those feature selection techniques. Our first feature selection technique was frequency, and here I applied that to select the top 100 n-grams by frequency. Our second feature selection technique was mutual information, and here you can see how I applied that to transform my feature vector X into an optimal set of 100 features based on mutual information. And finally, with syntax very similar to mutual information, I'm going to apply chi-squared to transform my X into the 100 best features according to chi-squared. So this demonstrates how to apply feature selection to get the best 100 features off of our n-grams. In the next lesson, we are finally going to be training a static malware detector. We're going to be using everything that we've learned so far and putting it all together.